More amplitude and period, but they're getting a little trickier on us. There's a sinusoidal function that has a maximum value of 3, there it is, and a minimum value of -3, which we do not see. This wave is going to continue downward. It'll eventually bottom out at -3, they assure us, and then start coming back up. So for amplitude, we find it using max minus min over 2. The maximum is 3, the minimum is -3. We divide that by 2. 6 divided by 2 gives us an amplitude of 3, to nobody's surprise. Now, the period is a little dodgy when we can't even see a complete wave, but we can work around that. This is half of a wave. Right? People who work with waves all the time know that a sinusoid that's drawn nicely, a sinusoid that's drawn decently, we'll live with that, is made up of 4 segments that each take up the same amount of space. They call this a quarter wave. From the middle up to the top of the hill is a quarter wave. From the top of the hill back down to the middle is also a quarter wave. From the middle to the bottom of a valley is a quarter wave. And from the bottom back up to the middle is a quarter wave as well. And if you've got quarter waves, it's not too much of a step to say that the hill is half of a wavelength and the valley is another half a wavelength. What they've given us here is exactly half a wave. And so we can look at this and say, okay, well, if half a wave is 6 units, then a full wave has got to take 12 units, twice that long. Therefore, our period is 12. Fair enough? You can do that if you have a half wave, and if we ever give you a graph that just goes wah, you can look at that and say, okay, well, this is a quarter wave. Let's say if that's 7 units long. If a quarter of a wave is 7 units, then a full wave must take 28 units. You can extrapolate from pieces of a wave if you can identify them well enough. So we have a period of 12. We have an amplitude of 3, and that means our function should look like, they said up above it was f of t is 3 sine 12t.